Hi everyone, welcome to my channel. In this video, we will learn about standard convolution operations in convolutional neural networks. What is convolution? Convolution is a mathematical operation used to combine two sets of information. In CNN, it helps to extract features from input images. Why are they important? Convolutions are crucial because they reduce the dimensionality of the images while preserving important informations. This makes it easier for the model to process and understand the images. What its role in CNN? In CNNs, convolutions are used to detect ease, textures, patterns in images. They help the network understand the content of the image step by step. This is mathematical expressions. The convolution operation can be expressed by this equation, but in CNN we use discrete convolutions. What is F? So F in here is input image and G the filter, or we can say it kernel. I and J is the position in the output feature map, and M and N position in the input image and filter. For example, let's say we have a 3 by 3 filter and 5 by 5 image. You always have to remember that your filter size always must be less than your image size. We slide the filter over the image, multiply the corresponding values, and sum them up to get the output. So the input and output arguments will be, the input is image matrix and filter matrix, and the output will be the feature map of the image. Let's start with the PyTorch implementation. First of all, we need to import torch and torch nn.functional. The latter provides the convolution function. Suppose we define a 5 by 5 image using torch.tensor. We also convert it to a float tensor and use unsqueeze, dimension is 0, twice to add base and channel dimensions, making it 4D tensor, because the convolution layer will take batch size, channel number, height and width. Okay, that is 4 dimension. We define a 3 by 3 filter and similarly convert it to a 4D tensor. So in here the output we can get, and we can use functional dot conv b2d and print the output. So functional PyTorch functional provide the function convolutions 2D. We can easily import them and we can easily use them. If you want to use TensorFlow, then you have to import TensorFlow library. Then similarly we will define 5 by 5 image matrix, and we can use TensorFlow.constant, and we can reshape it to a 4D tensor using TensorFlow.reshape. Now we also define a 3 by 3 filter, and we can also reshape it into 4D tensor, because for the mathematical operations we have to make both matrix in a same dimension. So our input image is 4D dimension, so we have to make the filter size also 4D dimension, right? Now we apply the convolution using TensorFlow neural network, where we can get the conv 2D that is also already built in TensorFlow library. Now you can just print the output. So that is the main basic operation of standard convolutions. That's it for standard convolutions. Next, we will look at depth-wise convolutions. If you have any questions, leave a comment below. Don't forget to like and subscribe.